Hello again everybody, welcome back. Part 2 on the security pins. So what we have today is we have a couple of extra driver pins. This is, I call them a driving spool because that's what you find in the driving, but they're mushroom spools, tapered spools. They have different names. And then we have a stepped spool, progressive spool. Yet again various names. We have some different key pins. We have a tapered key pin, a T-pin, and a threaded key pin. And we also now have a core that has been undercut, countermilled, whichever way you want to call it. So we can see how some of these can mess us about and trick us a bit. So we'll start off with the tapered spool. My key pin doesn't fit in to demonstrate this properly, but not a problem, we can just start it there. So like with normal spool, this doesn't really come into effect until another pin has been picked, and bing, gives us the full set, which is where we then have to think about picking this pin. So the difference with this compared with a normal spool is we get counter rotation as we push it up, and then we get our full set back. So we automatically think that's been picked. We put tension on there, but if we do carry on, we will get counter rotation, and then we'll have it picked properly. So it tricks you into thinking you've already managed to pick the pin when you haven't. Similarly, the progressive or stepped spool, we pick another pin, bing, drop into a full set. Then as we go up, we get a very, very deep full set because the centres of these are normally quite thin compared because of the steps. But then we actually have to fight getting it picked because we're there, but then we've got another step until we're open. So it does just make the lock feel completely different. If we go from a standard core, those same two pins, we can see will similarly do the same thing but give us more problems because of the threading in the core or the grooves. So yet again we pick a pin, bang, full set. So then we're trying to counter rotate, but we're getting clicks from here, and we carry on up with steps as we go. So as you can see, it's then having to counter rotate again, and so just more steps in the picking process before we actually get it picked. Likewise with this one, we get our full set, bang, we're into a deeper full set. This can quite often jam up the core, but we're having to do the same thing again, steps, but we're catching in the threads. So it feels completely different to a standard spool because of the steps you're having to take to get over it. So onto the key pins. We'll start with a standard driver and a T-pin. So we're putting tension on, we're pushing up, and as we push up, let's use the other just for the demonstration. So we're pushing up, and things are a bit too slippery on this, but we actually get to that point where we think we've picked the pin, but we've actually overpicked it. But we've got a full set, so we're keeping the pressure on, and we're trying to push on anything to see if we're getting any feedback, counter rotation, but you get very little from it. And it's not until you actually let the tension off that it will actually come down and turn. And the tapered keeping, which is something you see more in the commercial locks, effectively does the same sort of thing. It gives you that gap between the edge of the driver pin and the tip of the keeping to give you that opportunity to overset it. When you putting that in, then we've got a serrated keeping, quite self-explanatory, doesn't show it too well on this, but effectively you're fighting with this, nudging into bits and pieces on the core as it goes up, and especially if we get something with the undercuts, or counter milling. As we're trying to pick, we've got to deal with that, but that can then grab in anywhere else. But these sort of things come into effect more when you're actually combining pins. So say we have the progressive spool, grooves in the serrations in the keeping, threaded core. We get that initial full set as we had before. We then start pushing the keeping up, we get the deep full set. Now, not only are we dealing with serrations or threads, the sharp edges of the progressive spool, the different fin it gives us, but also having to work the keeping over the threads in the core. So threads in the core can also work quite nicely with the T-pin because we have that shoulder there. As we go up, they can help it jam up, and especially once we get into there, they can hold up the bottom of the pin a bit, make it harder. So as you can see, it's just combinations of all these different methods have different feels, which is why when you're making a challenge lock, something like that, it's worth taking into account how all these different pins react with the different cores and with the different keepings. So I mean, when we have this grooves and undercutting, which are specifically designed really for spools, we can get an extremely deep full set. We can jam up like so. We'd have to counter rotate, and we are jammed up again. And because we've got so jammed up, we're putting pressure on, and we've overpicked the pin. We can let it down a little bit, like so, and then we get a full set back, and we think we've picked it. And it's not until you let the tension off that you can actually pick it. So quite a lot there to absorb, but I hope you found that useful. I have had a lot of questions about doing pinning pins, which I'm trying to work out a way of getting it to work in here, and as soon as I do, I shall probably do a demonstration of pinning pins and how they work. But thanks for watching anyway, and I will see you again soon. Bye.